So we are doing this problem Pascal's triangle, and what we have to do is the way Pascal's triangle work is that we take the sum of, for getting the element at a particular position, this sum of the adjacent two elements in the previous row. So let us see how Pascal triangle works. So we have one. So we add these two. We have two and then one. We have one extra on the start. We add these two three. We add these two three, and we add extra one. Then we have extra one on the left. 4, 6, 4, extra one on the right. Then 1, 5, 10, 10, 5, 1. So this is the Pascal's triangle. In the problem, but they are saying that if we will give you the row number, and for if row number is 1, you have to return this array. If row number is 2, you have to return the second row in the Pascal triangle. For 3, you have to return this 1 to 1. For 4, you have to return 1, 3, 3, 1. Okay. Now let us look at the approaches. So one is the recursive approach. So it does exactly what I just mentioned to you, that one, one, one. So firstly, what happens is that say we are looking the solution for uh, yeah. Let me check. So let's say we are looking for the row number 5. So for row number 5 is this one. This is 1, this is 2 row number, this is 3, 4, 5, 6. So you have to get the row number 5. So the recursive solution, let me copy the solution. In this case, what we do is, if row number is 1, we just return the array of 1, right? But if it is greater than 1, then we get the previous row. So from we wanted row number 5. So firstly, row number 5 is makes a recursion call to Pascal triangle row Pascal triangle row 4. It means a recursion call to Pascal triangle row 3. It makes a recursion call to Pascal triangle row of 2. It makes a call to Pascal triangle row of 1. So in this is the base case. So this 1, if row number is equals to 1, we return this array which contains 1 as the only element. You can see current row is empty array. We append 1 to it and we return uh, that current row. So in this case, for Pascal triangle 2, uh, now we are running this function, right? We are on this function, and the previous row is this 1. This array with a single element 1. Now, what we do for the current row has 1, right? In that we append previous row of I minus 1 plus I. So in this case, we start I at 1 and length of previous row. So length is 1. Length of the previous row is 1. So 1 comma 1. So this in this case, just for loop doesn't runs, and we come to this line. We append 1 and we return the current row. So PTR of 2 returns 1 comma 1, and this call finishes. For PTR of 3, partial triangle row of 3, we have the previous row equals to 1 comma 1. Now current row. contains just 1. Now I is initialized at 1 and we go to length of previous row. So from 1 we go to length of previous row is in this case 2. So from 1 to we go 1. Let us think about it like from 1 to 1 basically inclusive. So we run for 1. So in this case we append current row to a current row previous row of I minus 1 comma previous row of I. So 1 minus 1 is 0. So previous row of 0 comma previous row of 1. So which is 1 and 1. So we add these two and append it. So 1 plus 1 is 2. And then we append 1 to current row. So for PTR3 the result is 1 to 1. So this PTR3 so returns 1 to 1 and this is the previous row for PTR4 call. So this 1 to 1 is here now. 1 to 1 is the previous row for PTR4 call and we can just remove this. Now this call has finished. For this the current row is current contains just 1. Then we run from I from 0 not 0 I from 1 till we run I from 1 till length of previous row which is 3 and uh, we basically run till index 2 only. So for 1 and 2 index, right? So 1 and 2 index it runs. So what we do is we add the 0th index for 1. When we run it for 1, we basically look at the previous left of it. So 0th index and first index. So 0th index and first index. So it becomes 3. We append 3. Then for 2, second index and first index. 2 plus 1 is again 3. And then we append 1 to current row. So current row becomes 1331. This is the result that we return from PTR4. 1331. So this is returned by PTR4 1331. And you can see that this is the fourth row, right? So recursion basically because the result of the 5 is derived from the previous row only. So we can use recursion in this case. So now previous row is previous row is 1331, right? For PTR5. For PTR5, basically for PTR5, we were getting the result from PTR4 and we were assigning it to previous row. So PTR4 was 13341 and previous row for PTR5 will be 1331. Now current row contains just element 1 and we run from I from 0 till 4 minus 1 that is 3. 1 to 3 from 1 to 3. So when I is equals to 1 we get these two elements at 1 index and 0 index, right? So and add it and append it to current. Then for I is equals to 2, when I was here I equals to 1 then I is moved one step to the left. I is moved from one step to one step to the left. So I is 2 and we add the element at first index and second index I minus 1 and I. So it becomes 6. Then I is 3. We add the element at second index and third index, so it becomes 4. Right. Now for I is equals to 3 was the last that we wanted to run. Now this for loop exits and then current row we append 1 to it. So this is the row number 5 that we have. So PTR 5 returns 14641, which is the desired answer. Let us look at the next approach, which is the iterative approach, which is similar to what we done in the recursive approach. It is just that it is actually, I think, easier to understand. So I just included it in the solutions. Now, so firstly the result is 1. For second row, what we do is we firstly store the result in the previous array. So previous array becomes 1. In this case, like for j, this loop doesn't actually does anything in this case. Basically, length of previous is 1. So 1 to 1 is we don't run this loop. We just add result 1 to the result. So this here we have just 1 and 1. Then in the second step, 1 and 1 is stored here. The correct result is stored in the previous array, and then the result of j. So the result of 1 is equals to previous of 1 plus previous of 0, right? Previous of 1 comma previous of 0. So result of 1, here we store 2, which is sum of these two, right? And we at the end we run this line, so we append 1. And then in the next step we run this, previous is 1 to 1. Now at this index at for 1, this becomes sum of these two, so this becomes 3. Now this becomes sum of these two, so this becomes 3. And then at the end, after exiting the for loop, we append 1, right? Then the previous again becomes this array, result actually remains the same. So let me just write it 1 3 3 1. Now at first index we get the 0 in first index, so here we get 4. Then this index, this is 0 1 2 3, 0 1 2 3. So at 2 index we sum up 1 and 2 of the previous. So 3 plus 3 is 6. 6. Then we run J for last index, so which is 3. So at 3, this here what we had is 3, we have 3, right? We had 1. So the value was 1, but it is updated with this 3 plus 1. So this becomes 4. And then at the end we append 1 to the result. So this is the fifth row that we desired. This is now this for loop exits because for 5 basically row number was 5, right? So 5, so we run it for row number was 5, yeah. So now this for loop exits and we basically return the result, which is this array. So this was the iterative solution, and the next is combinatorics approach. In this, if you look at the fifth row is 1, 4, 6, 1. Now, if we calculate, these are exactly actually 4C0, 4C1, 4C2, 4C3, 4C4. So fifth row of the Pascal's triangle is actually this 4C0 till 4C4. What is a third row? What is fourth row? Let us look at fourth row. Fourth row was 1, 3, 3, 1. So this is 3C0, 3C1, 3C2, 3C3. Now, how is the now you can look at like this is mathematical concept how 4C1 is calculated. It is calculated as 4 factorial upon 4 factorial, then this 1 comes down here 1 factorial, and then this n minus r 4 minus 1 factorial. So 4 factorial by 1 factorial by 3 factorial becomes 4 over, yeah, it becomes 4 because 4 factorial 4 into 3 factorial upon 3 factorial 1 factorial is 1, so this gets cancelled and we get 4. So you get 4 here. So if we just calculate this combination values, we have the Pascal triangle rule. So this is what we are doing in the solution. You can see we are using math.com function to calculate like we are doing NCR. Firstly, one thing we are doing is we are decrementing row number by 1. So n becomes row number by 1. So because for fifth row, for row number 5, we had to do 4C0, 4C1, 4C2. So that's why we have decremented and we have reduced row number by 1 stored into n, calculated the combination for r from 0 to n. 0 to n. So you can see from 0 till 4 it goes. Okay. Now the next solution is optimal approach. Now this combinatorics approach is actually inefficient in this case because uh, calculating this 4C2 is actually not so efficient. Like in Python code, it is just calling a library function, but let's look at the C++ code. Here we are calculating the uh, combination using a for loop, and we are pushing that combination result to our row that we need to obtain. So let me just since we are looking at the solution, let me describe you how this combination is calculated in code. Okay, so in combination starts at 1, and let's say we are calculating 4C2. So I runs from 0 till 1. Okay, because we are doing less than r. So NCR. So from 0 till 1 inclusive. And what we are doing is n combo of n minus I upon I plus 1. So we multiply this 4 minus 0. In first case, we multiply by this upon I plus 1. So I is 0. I is 0, so 0 plus 1. And then we again multiply comb by, and I is equals to 1. We do 4 minus 1 upon 1 plus 1. That is, okay. So comb was 1. So 1 times 4 by 1 times 3 by 2. Right. So this is actually 6, which is the value of 4C2. So 4C2 is 4 factorial by 2 factorial, 4 minus 2 factorial, 2 factorial. So it is 4 times 3 times 2 factorial by 2 factorial, 2 factorial, 2 factorial gets cancelled. What is this 2 factorial? It is 4 times 3 by 2 times 1, right? So this is exactly what we are doing. 4 times 2, and this bottom factorial gets reversed. So 1 times 2. So this for loop is actually calculating the combination correctly for us. Let me show you one another example. Let us calculate it for 4C3, let's say. So I will go from 0 to 2 in this case. So combination is 1. We multiply it by 4 minus 0 upon 0 plus 1. We do 4 minus 1 by 1 plus 1, 4 minus 2 by 2 plus 1. So 1 times 4 by 1 times 3 by 2 times 2 by 3, right? So this is 4, this is 4. If we calculate 4C3, then what we will do? 4 factorial by 3 factorial, 4 minus 3 factorial, 1 factorial, 4 factorial is becomes 4 minus 3 by 3 factorial times 1 factorial. Actually, what we are doing is we are not cancelling in this case. Let me just show you another one. 4 times 3 times 2 by 3 times 2 times 1. So this is what we are exactly getting right. This bottom factorial is reversed, and and on the upper side we have a 432. So this calculates our combination. Okay. So, but this calculation of this combination takes big of n time. So this solution becomes big of n square actually, because we have outer loop here, we have inner loop here. So this runs for n operations. This takes n time. So n times n, because this is inside. This loop is inside of this loop. So n times n becomes n square. N square time complexity. This is not efficient. So for calculating the combination of NCR, we can look at this approach. We can use the previous calculation to calculate the current NCR, NCK. So NCK is equals to NCK times n minus 1 and n minus k plus 1 upon k. Here is the proof of that solution, proof of that formula. And in the solution code, you can see that the Pascal rho of k is equal to Pascal rho of k minus 1 times n minus k plus 1 upon k. Okay, so let us see how this formula works. Then I will even derive the formula later. Okay, so what we are doing is, so I is 1, then what we are doing is the result of 0 times n minus k. N is, if we are designing row number 5, then n would be row number minus 1, that is 4. So times 4 minus k. K is 1 plus 1 divided by 1. So times 4. So result had 1 earlier, and this time we do result 0 is 1. So 1 times 4 minus 1 minus 1 plus 1 becomes 0. So time 1 plus times 4 is 4. Okay. When we calculate the result of 2, we do we do result of 1, result of k minus 1, that is 1 times n is 4, 4 minus k is 2 plus 1 upon 2. Yeah, I got it. So in this case, what happens is we actually perform this row division on the multiplication result. So result of 1 is 4. Then we do 4 times 4 minus 2 plus 1, which is uh, 4 times 4 minus 2 plus 1 is plus 1, 3 upon 2. So 4 times 3 is 12 upon 2, which is 6. So we add 6, right? Okay, result of k becomes 6. Then result of 3 is calculated. Result of 3 is calculated as result of 2 times 4 minus 3 plus 1, 4 minus 3 plus 1 upon k which is 3. So 6 times 2 upon 3, which is 12 by 3, which is 4. So now we have 4. The point that I got confused earlier about is that this division occurs at the end. So basically, when we have this operation, so multiplication is performed first and then division is performed. So multiplication and division are performed from left to right. So firstly, this multiplication is the basically evaluated. Don't divide this, because if you flow divide this 4 minus 3 plus 1 by 3, if you flow divide this, so we become 2 by 3, it will become 2 by 3. 2 by 3 is 0. In floor division, it will become 0. You multiply it by the result of 2, it will become 0. So we don't perform division first, we perform multiplication first. So just if this confusion occurs to you, then I'm just uh, clarifying it to you beforehand. Okay. Now result of 4. Result of 4 is calculated as the result of 3. Result of 3 times 4 minus 4 plus 1 divided by k, which is 4. So 4 minus 4, 1 upon 4. So result of 3, 4. So it becomes 4 times 1 by 4, which is 1. So at end we have 1. So this is the result array. This is the fifth row of Pascal triangle, and we return it. So that's the end of lecture. Bye bye.